Today's video is on finding the area of rectangles and parallelograms. Many students are aware of what area is, but lack the basic understanding of what it actually means. Students know, oh, we multiply the length times the width to find the area of a rectangle. That's great. 3 times 7 does indeed equal 21. But you need to understand what that 21 represents. If you count out all these squares in this rectangle, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, you'll see there are 21 squares in here. So if this represents 7 centimeters and this is 3 centimeters, this is 21 square centimeters. And that's what area represents. It's how many squares fill that space. Now, the formula, again, is length times width. That actually can be used for squares as well, length times width. The length and the width would just happen to be the same value with a square. So you would do 3 times 3, and you'd get the area of 9 centimeters squared. It's worth noting that the square can also use the formula side squared, which would just be the side length times itself. You'd still get the answer of 9 centimeters squared. It's just a different formula to use. The idea, though, that you can use the formula length times width on all rectangles or squares may be more convenient. Finding the area of a parallelogram really is derived from the formula for finding the area of a rectangle. Because if you think about it, a similar rectangle, 3 centimeters by 8 centimeters, we all know length times width will be 3 times 8 equaling 24 centimeters squared. But if we took this small rectangle, cut it out, and moved it over here, or in this case took the rectangle or took the parallelogram and cut the triangle out and moved it over here, you could interchange what makes a figure a rectangle or a parallelogram. And the idea is that same amount of space would still be there. So the area would be unchanged. So what we realized is with a parallelogram, the formula is base times height. The base being 8 centimeters and the height being 3 centimeters. It's worth noting that every time you have the base and the height of a parallelogram, the base and the height always meet at a right angle. Now with a rectangle, you always have right angles for the whole figure. So essentially you're doing the same multiplication, it's just in a different location. But the bottom line is the formula that we use for finding the area of a parallelogram is to multiply the base times the height, in this case 8 times 3, which would equal 24 centimeters squared. Every time we find area of a parallelogram or a square or even a circle, the area is always going to be in square units because that's what area is representing, that second dimension, how much space an object occupies. So when we have a parallelogram, we've got to be careful because sometimes there can be additional labels. For example, this might be 9 inches, 9 inches, and 7 inches. We want to use the base and the height, the two items that meet at a right angle. So in this case, we would do base times height, or 7 times 7, which equals 49 inches squared, is the area of this parallelogram. In the case of this parallelogram, they've already labeled everything for you. Again, base times height, so 10 times 6 equals 60 inches squared. In the last two examples, there's some larger numbers, but it's still the same concept. Your base times your height. So you would do base times height, or 20 times 25, which equals 500 meters squared. Now, in this situation, you can see the parallelogram itself, the height is not part of the parallelogram. But if you could think of the bases extending themselves, okay, you're basically finding the distance between the two bases at a right angle. So there's your right angle. So your height is 18 inches, and you're only measuring the actual base of the parallelogram. So in this case, base times height would be 7 times 18, and 7 times 18 is, 7 times 10 is 70, 7 times 8 is 56, so you're looking at 126 inches squared. All right. Thanks for sticking around till the end.